Hello everyone. This case is about real-time bank transaction fraud detection. So basically detecting fraud transactions in real time using the AI techniques and various rule-based monitoring. So we have taken a synthetic data which is generated by LLMs, and on that data the whole project is based. So basically we want to reduce fraud losses by greater than 25% within 3 months versus baseline. Then we want to maintain approval rate of greater than 97%, overall step up rate less than 2.5%. These are the metrics on validation, latency, in how much time we should be able to detect. The model must respond in real time within 50 milliseconds at the 95 percentile latency. 99.9% availability. It should be always available. This is data overview. These are the various fields which are there in the synthetic data. So amount, channel, merchant category, country, is cross border, whether it is transaction is across countries or not, device age, account tenure, risky flag, merchant fraud rate, last transaction hours, and multiple such fields are there. So basically we want a positive class which is a confirmed fraud, and then there is a negative class, so which is a not fraud, legitimate transaction. And we train on transactions which are older than 45-60 days so that their actual status is clearly recorded, because sometimes it takes time for the transaction to be marked as fraud. We use features which are available at authorization time only, so that any future or past features are not used, so that it doesn't lead to any issues. Yet EDA will help us to plot graphs which will give us more information about how the data is and what all are the categories, what we should do next in feature engineering. It will help us to find out the imbalances of the classes, because here the fraud transactions are very less as compared to the legitimate transaction. Then leakage checks. So EDA basically helps the rest of the project. In feature engineering, there are transaction features. So we derive hours of day, day of week, cross-border flag, risky buckets, then velocity aggregates. So frequency and intensity of activity over short windows. So if there is a lot of transactions happening over a short window, then that should be considered as one of the feature, and it's basically a fraud burst fraud behavior basically. Then geography and behavioral features, like whether what speed need to travel from last transaction location to current one, impossible travel, then entity risk priors, so encode the prior knowledge about riskiness of the entities, and sliding window and leakage prevention. So we have to always keep in mind that we have to compute aggregates which are related to transactions timestamp and not using the entire data set, otherwise that will give wrong this thing. This improves model discrimination, supports explainability, and enables rules plus ML fusion basically. So our modeling approach is we use models as well as we use rules. So models help us in capturing the subtle multi-feature interactions. Logistic regression, random forest, calibration layer is used over here. And then there are rules, hard rules. So first of all, the rules are the one which actually parses on the transactions, and then if very easy to catch transaction fraud, it is taken care of by the rules, and then it goes ahead for the ML part. So gateway receive transaction rules pre-filter runs first, then ML model scores the transaction, and threshold based decisioning is done. So this leads to low latency and guardrails are in place. So models and rules together, they lead to intelligence and guardrails basically. And a real-time fraud engine is able to make fast, safe and explainable decisions. So the pipeline is there. Then we have the regression models, class imbalance handling, because the fraud prevalence is less than 1%, so imbalance must be explicitly handled. So balance subsampling is there, focal loss, there are various methods of handling the imbalance. Then there are metrics which are critical for this particular algorithms, models, PR AUC, ROC AUC, F1 MCC threshold, slice matrix, cost function, threshold selection. So based on this matrix, we finally come to the best algorithm. So real-time scoring has to be done within low latency. So as soon as the request is received, it gets passed through the rules and the pre-filters, and then ML scoring is done and further decision is taken. Governance, security and compliance plays an important role over here. PII we have to handle, PCI we have to handle. So we have to do encryption also, guardrails should be there, access control should be there, who can access what, auditability is very important, regulatory, whatever are the regulatory protocols we have to follow depending on the acts prevalent in that particular country. Guardrails actually helps in explainability so that we can explain with confidence why this transaction was marked as fraud. We'll also go through the code once. So this is the code which actually simulates the same thing which we saw in the Word file. The data is loaded, it is divided into training and test data, EDA is done, then modelings, all the models are evaluated, rules are there, thresholding is done basically to minimize the expected cost. Then based on the evaluation, the actual best model is selected. We have a fast API configuration available for taking in the input and giving the output. Data synthesis is done. Here we talk about the EDA part, then pre-processing and models. One hot encoding is done to convert categorical feature into numerical feature. Column transformer is there. Logistic regression, random forest classifier and gradient boosting classifier. Then we do the metrics and thresholding are printed, and then the rules plus ML decision workflow follows. And this basically helps in giving the final output. Training, selection, yeah. This is the fast API part. Yeah, that's all. Thank you.